Hello there, my name is Emma. My teammates and I are here to present to you on how 5G can be used as an enabling technology for building of smart ports. Now, first of all, let me give you a little bit of an insight about smart ports. Ports in general play a vital role in international trade and the prosperity of a nation, as approximately 90% of global trade relies on maritime transits. Based on statistics, nearly 75% of port supervisors stress about how crucial automation is for maintaining market competitiveness. So, what is 5G? 5G is the fifth generation mobile network. It is a new global wireless standard network which is designed to connect virtually everyone and everything together, including machines, objects, and devices. 5G has a dense and distributed access architecture which enable faster data processing. So how fast is the 5G technology? 5G can be significantly faster than 4G, delivering up to 20 Gbps peak data rates and 100 plus Mbps average data rates. As 5G is advancing at an incredible rate that enables self-driving cars, lifelike VR AR, and 4K streaming on mobile devices. However, 5G is about more than just how fast it is. In addition to higher peak data rates, 5G is also designed to provide much more network capacity by expanding into a new spectrum. Not only that, 5G can also deliver a much lower latency for a more immediate response and can provide an overall more uniform user experience, so that the data rates stay consistently high, even when the users are moving around. Here are some comparisons between 4G and 5G. To summarize the given comparisons, 5G wireless technology is meant to deliver a higher multi-GPS peak data speeds, a larger bandwidth, a lower latency in milliseconds, and a higher number of carriers, which in turn provides a more reliable and stable network.
There are a few characteristics of a 5G network. First, a 5G network boasts a peak download and upload rate of 20 gigabytes per second and 10 gigabytes per second, respectively. Besides, it also has an extremely low network latency, which is between 1 millisecond and 4 milliseconds. Not just that, 5G networks transmit data using a full duplex transmission. The full duplex transmission allows transferring and receiving data simultaneously. Previously, two frequencies had to be used if data were to be transmitted and received simultaneously. However, this wouldn't be the case for 5G networks. Moving on, I'll introduce the technologies that a 5G network utilizes. In 5G networks, waves, also known as millimeter waves or high band 5G, are used. Waves are frequencies starting at 24 GHz and beyond. This technology used to be exclusive to satellites and radar to transmit data in the past, but that is not the case now. As radio waves increase in frequency, each wave narrows in length. This allows high precision frequency broadcast towards any 5G compatible device while preserving high data transfer speeds. This results in a high download and upload rate and a low network latency, which was mentioned earlier. Next, small cells are used in 5G networks. As opposed to waves, small cells existed back in the 3G days and they have been in use since then. Previously, small cells were used to enhance network coverage to expand user connections in 3G networks or used to improve network rollout capex to intensify network coverage in urban areas or by large corporations to improve network performance in 4G networks. When the 5G network rolls out, you will be able to connect with internet-enabled devices such as smartphones, Internet of Things IoT devices, and even futuristic applications that are still in the works. Small cells are used to provide the capacity for these handheld devices and the connectivity for IoT sensors. Since small cells can densify network coverage, it assists 5G networks in maintaining multi-gigabyte data transfer speeds even with a high user capacity. Besides, extended coverage and low network latency are also two of the perks of small cell usage. On the other hand, 5G networks also use an innovative technology known as massive MIMO. The term MIMO stands for multiple inputs and multiple outputs. It increases the number of user connections that are allowed while being able to send and receive data at full speed. Compared to 4G networks, it increased the capacity of 5G networks by a factor of 22 or above. Lastly, beamforming is one of the cutting edge technologies used in 5G networks. Essentially, it is a traffic signaling system for base stations. It searches for the most optimal data transfer path for all connected users while minimizing any interference for neighboring users. Combining it with massive MIMO helps it achieve higher spectrum efficiency.
Now that we know about the characteristics of 5G, let's move on to the smart board. So what exactly is a smart board? A smart board is a board in which many functions are totally automated and digitalized. It may employ emerging technologies like AI, IoT, blockchain, big data, and 5G. Smart boards are intended to address and correct the shortcomings of their conventional predecessors. Smartboard is also crucial to the country's economy as it will help to automate the various processes in traditional port while also ensuring data is transferred at a quick rate to boost the processing and handling times. The problems with the current ports right now is the high cost of labor and a high safety risk level. There's also an inefficient planning of the labor force. Not only that, accidents might cause significant amounts of downtime and many were concerned about the security issues.
There are several methods being developed to implement 5G in smart pods, such as automatic control of gantry cranes. As of right now, each gantry crane requires a human operator to be physically there. By using 5G, this allows the cranes to be controlled directly from the control room, allowing multiple cranes to be controlled by a single operator or by artificial intelligence. This also opens the door to 24-hour operations. Secondly, is video surveillance. Current surveillance systems can be upgraded by integrating facial detection, container tag monitoring, as well as ID plate detection. This is made possible as 5G has a larger bandwidth and lower latency. This allows for more cameras to be installed throughout the perimeter and reduces delay, helping to increase security and safety around the port. Finally, intelligent guided vehicles can be implemented. The current automatic guided vehicles can only work along their pre-programmed tasks. Hence, they can be upgraded to IGVs. The vehicles can connect to the control room directly or with one another. This increases efficiency and reduces the risk of collisions between one another or human workers. This is made possible as IGVs require an immense amount of sensors and data to be communicated across the network in order to navigate accurately. And only 5G can satisfy latency and bandwidth requirements. Here is an estimated list of latency and bandwidth requirements regarding the pre-mentioned changes.
Next part is challenges. 5G promises a lot to attain these goals. 5G networks must be unique. So these are some of the challenges that 5G are facing, which is network architecture, ultra low latency requirements, operating expenses, and also security. So let's talk about network architecture in depth. Engineers have problems employing this architecture because 5G is more dense and its high throughput, low latency requires small cells. Due to root loss, its high frequency spectrum also needs more cells, site acquisition, power requirements, and logistic, which will make the cell deployment difficult. It is a new technique that demands a new operating model, which is different and difficult from its earlier incarnations. For example, implementing this infrastructure for 5G networks require expertise of server virtualization, networking, storage virtualization, and cloud computing, as well as telecom domain familiarity with the new architecture. Next is the expenses. 4G to 5G transition is expensive. 5G equipment is a major cost because it comprises routers and switches as well as the new base stations needed for the coverage. 5G equipment costs have been failing, but there are other running costs. Configuration will involve particular skills and expertise, hence making it more expensive. Software updates and network testing cost money too. 5G also requires a new spectrum licenses. The next challenge is ultra low latency requirement. To accomplish these low latency requirements, there are various technical obstacles. Engineers must consider network traffic, physical layer infrastructure, and routing protocols. The network must also use beamforming and massive MIMO and have large density of small cell sites, which has been explained earlier in the video. And the last one is security. 5G networks will task telecom engineers to ensure performance and cybersecurity threats. 5G networks will use compact cell towers in densely populated locations. This density will heighten cybersecurity threats. One of it is denial of service, or in other words, is DOS attack, in which bad actors overload the network. The next part of the video is the 5G in the OSI layers, which will cover the transport layer, network layer, and also the physical layer. Firstly, let's talk about the transport layer. The transport layer uses the TCP protocol. Congestion control is one of the mechanisms. TCP congestion control algorithms that are not capable of distinguishing between various sources of packet loss. To reach the desired performance in 5G, the algorithm congestion window size must be adjusted. Because of the success of 5G congestion control, low latency can be applied. In smart ports, autonomous drones are used for inspection and maritime monitoring. Because of the capabilities of 5G network architecture to handle congestion, hence there is no jitter.
Initially, Seaport is outfitted with installed machinery and is linked to the network via wires. Trading takes place around the world through seaports, which require a dependable network to track, and the existing 4G network cannot match these requirements due to its constraints. Smart ports make use of network slicing, which is common in 5G and beyond. The network layer, sometimes known as the core network, provides a variety of functions. High bandwidth, dependability, and connection density are achieved through networking slicing. Customers can install cameras and update the AI algorithm as needed. Wireless gadgets operate in sleep mode. To avoid delays, the devices respond promptly after receiving a packet from a network. To avoid latency, the devices examine incoming network packets on a regular basis. This approach allows for the establishment and termination of a connection to a communication channel, increasing the efficiency of smart ports. The integrated communication system allows for high speed and high bandwidth connectivity. It allows for more data and signal transmission capacity. In conclusion, the deployment of 5G technology is a critical enabling factor for the development of smart ports. Smart ports are able to use data and analytics to improve operational efficiency, reduce costs, and improve safety. 5G will enable real-time monitoring and control of port operations, as well as provide the high bandwidth needed for data-intensive applications such as video streaming and virtual reality. In addition, 5G will enable the development of new services such as autonomous vehicles and drones. The development of 5G at ports will be a key enabler for the future development of smart cities.